The 18th of March, 1945. Kasanohara Naval Air Base, Kagoshima, Prefecture, Kyushu, Japan. The morning haze clings to the rice paddies beyond the perimeter fence. A guard hears it first, a ragged prop note limping out of the south. Then you see the silhouette break through low cloud, a bent gull shape that does not belong here. The watchers on the flight line know the outline by now. F4U Corsair, American. The patrol siren coughs into life. Men scatter. The aircraft staggers over the treetops, crosses the field and drops its gear late. One tire blows on touchdown. The fighter veers sloughs in dirt and comes to rest with its nose low and left wing dipped dust drifting around the long blue fuselage. Marines had a name for this machine. Some called it whistling death for the sound of air through its wing root intakes. But on this field, it is an engineering event. Shore parties move first, rifles up, then maintenance hands jog out with chocks and a fire cart. The canopy slides back. No return fire, no pistol. The pilot is gone, bailed out seaward or pulled from the wreck by villagers before the patrol arrived, and the airplane sits like a challenge in the middle of an enemy base. Fabric tears show on the port wingtip, a streak of oil trails from the cowling seam. But the big Hamilton standard prop is mostly intact, and the landing gear, though raked, is standing. Word runs by telephone and motorcycle to the nearest intelligence post. Within hours, a small detail from Yokosuka. 1st Naval Air Technical Arsenal is on the road south. Their mandate is simple and urgent. Recover Allied airframes, catalogue their construction, learn what can be learned. They carry tape measures and notebooks, calipers and contour gauges, cameras and chalk. They have seen P-42s and B-24 parts, an F-6F Hellcat in pieces, a B-29 tailplane. They have not had a Corsair on Japanese soil upright nearly whole. Not until now. The crew circles the fighter in a slow, disciplined dance. Notes first, photographs second, touch last. The cowling comes open on its latches with a clank and a hiss of cooling oil. Inside the Pratt & Whitney R, 2800, double wasp fills the bay like a steel furnace. 2 rows of 9 cylinders, ignition harnesses, laced tight baffles, cut and riveted with a regularity that looks machined rather than hand-fit. One engineer runs a finger along a safety-wired fastener and writes down the wire gauge. Another calls out fastener spacing on the cowl flaps and gets back a number so consistent across panels that he stops, frowns, and measures again. They move to the wing root. The inverted gull geometry that Japanese pilots have described in reports is more extreme on the ground than in the air. The root drops hard from the fuselage, then kicks back up toward the tip, a shape that solves several problems at once. Short landing gear with prop clearance, lower drag at the wing, root room for big guns, and retracting wheels. Here the Arsenal men find a library of manufacturing decisions laid bare. Forged hinges stamped with inspection marks, lightning holes with polished edges, ribs with joggles that align at every station. They compare it to the wing box of a Zero or a George and trade quiet glances. The Zero is elegant and light. This is elegant and strong. The cockpit canopy long and framed rides on tracks that slide clean despite dust. Inside the stick is heavy in the hand, the throttle quadrant smooth. Placards are printed in English units. The radio set is intact crystals still in their rack. A technician unbolts a panel and reveals cable runs secured with clamps at exact intervals. Another man checks for armor plate and finds it, behind the pilot beneath the seat at the windscreen. He taps the glass. It is thick and slightly green at the edge. On the underside, beyond the mud on the tire and the torn fairing, they locate hardpoints for bombs and rockets. The wiring looms for the HVAR rails are bundled and numbered. Ordnance fittings are overbuilt by the standards of light naval fighters. This, one of the men says, is not designed for dueling alone. This is a fighter that carries war forward in weight. 8. 50 caliber. Browning M. 2 guns, ammunition boxes, packed feed chutes, shaped to prevent jams when pulling high G. He has read the combat reports from the Solomons and Rabaul from the Central Pacific push, and the numbers are there in the margins claims. In the thousands losses, in the low hundreds, 11 to 1. The pencil rests on that figure for a long breath, then moves on. By late afternoon, the Arsenal team chalks inspection lines along skin seams and circles rivet rows that look different from Japanese practice. The difference is not just materials, it is uniformity. Holes are true, spacing is metronomic, and every bracket seems to have a brother on the opposite side cut to the same tolerance. They talk quietly about jigs. They talk about subassemblies arriving in crates, ready to pin and rivet without hand-fitting. They talk about a factory that can build 1,000 of these in a year without losing accuracy. In the hangar, a camera flashes. A mechanic holds up a measuring rule across a gun bay, and the shutter snaps again. As dusk gathers over Kyushu, the Corsair is winched onto a dolly and towed toward a shed. Guards pace. A tarp goes over the canopy. The wind from the bay carries the smell of salt and burned avgas. Somewhere inland, an air raid siren on a hilltop yawns into life and then dies again. The men from Yokosuka climb into their truck with notebooks full and faces closed. Tomorrow they will begin the strip. Cowling off, guns out panels, tagged hoses, drained systems, traced weights recorded. Tonight they drive north with a clear thought that hangs between them like the scent of oil. This enemy fighter is not a miracle, it is a system, and the system that built it may be the thing they have not matched. The 20th of March, 1945. Yokosuka, Naval District, 1st Naval Air Technical Arsenal. Sea mist lifts off Tokyo Bay and rolls across the concrete as the Corsair arrives under canvas wheels chained to a flatbed. The tarp comes off. Floodlights hum. A chalked bay number a stack of wooden trestles, a kit of tools laid out with ritual neatness. The team has a method: photograph, weigh, measure, tag, and map. Each panel is scored with a grease pencil, each fastener counted before a screwdriver ever turns. When the first cowl segment drops into a canvas sling, it is not a trophy. It is a data point. They start at the nose. The Hamilton Standard hydromatic prop hub is opened with pullers and wooden blocks to avoid gouging the alloy. The hub machining is precise, sealing faces true safety wire, neat and consistent. Notes record part numbers and inspection stamps. Sumitomo had built Hamilton Standard types under license. The forms are familiar, yet the finish quality here tightens the throat. The prop governor is tested on a bench rig. Response is crisp, backlash low. One engineer jots a line: tolerance control excellent. The cowling clears, and the R2800 lies bare beneath the gantry. Two-stage, two-speed supercharging fills the front bay with a maze of ducts and intercoolers. The men trace the path: air intake first stage, intercooler second stage, diffuser cylinders. Baffles are sealed with rubberized strips to force cooling air where it must go. The engine mount is a web of steel tube cleanly welded with gussets that spread load into the firewall. They check the cylinder fins spacing and find identical counts row to row. No hand filing. Fixtures, jigs, a system. The electrical harness is unwrapped in sections, each branch tagged with a linen marker printed in factory type, each connector crimped and soldered with repeatable angles. Zinc chromate primer glows dull green on interior faces. It is more than paint. It is corrosion control with chemistry in the formula. Japan has struggled for uniform anti-corrosion finishes since the supply chain tightened. Here the primer is everywhere it ought to be, thin, and even never puddled, never missed. Wings come next. The inverted gull breaks at the root spar caps, stepping down toward the gear bays. They lower the gun access doors. 8. 50 caliber Browning M2S sit in their trays with feed chutes that sweep cleanly from ammunition cans. Guides are polished. Ejector ports are shielded. An armourer unrolls a canvas and checks headspace and timing as if on a flight line. The gauges settle without fight. The ammunition box doors reveal spring stays that hold themselves open at a precise angle, hands-free for loading. Someone chuckles once and writes it down. Good design is not loud. It is the thing that never makes the crew swear. They drive pins and pull the right main gear to a scale. The oleo is robust by naval standards, stroke long for rough fields. Bearings are sealed. A parts list grows on a clipboard with weights in kilograms and conversions to pounds for any post-war report. Flush rivets run along the leading edge, where drag matters. Universal heads march where they do not. Every 5 rivets a witness mark. Every station a duplication across the center line that matches within a millimeter. 2 men slide a contour gauge along the fillet fairing and hold the impression to the left side. It fits like a lid. In the cockpit, the story is systems integration. The seat and armor plate weigh more than some entire sub-assemblies on the light naval fighters they know. The canopy rails ride true after grit is blown away. The throttle quadrant mixture and prop control sit under one hand, detents confident but not stiff. The radio bay carries multiple sets, with a tidy loom's map antenna leads routed with mind to interference. The oxygen system is marked in stenciled English, the plumbing secured with P-clamps, at perfectly even spacings. The sight sits steady on the panel. No frills. Clear. They strip the belly and find hardpoints wired for bombs and HVAR rocket rails cabling numbered and protected from chafe. The wing skin thickness increases near attach points in smooth planned steps, not ad hoc doublers. The arsenal has weighed enough zero wings to know the difference. A zero is a blade. This is a hammer that knows how to fly. Comparisons creep into the notebook margins despite themselves. 2-stage supercharging at this reliability is rare in their service. Turbochargers exist, but production is thin, heat-resistant alloys thinner. Hand-fitting is a point of pride in several home factories. Here, hand-fitting is removed from the critical path. Sub-assemblies appear to have been drilled and jigged in nests, then married on lines that hold tolerances by design rather than by craftsman rescue. That thought hangs heavy. It is not that the workers are better. It is that the system refuses to allow worse. By evening, a parts forest grows across trestles. Each piece wears a paper tag with a serial, a location code, a weight, a short verdict. Good? Very good? Uniform? The phrases repeat. One engineer sets a rivet sample in a small vise and cuts it clean to examine the shank under a loupe. Expansion is even. Hole quality is high. Around them, typewriters clack as pages are carbon copied for distribution. Outside the bay, horns moan, and the light on the pier goes red, then green. They step back at last and look at the Corsair reduced to bones fuselage on stand spars like a bridge without its deck. The lesson is not hidden. It is everywhere at once. Precision at scale. Protection against failure. A cockpit that thinks about a tired pilot's hands at night over water. They did not expect sorcery, and did not find it. They found discipline and repeatability, and they know what that means when multiplied by factories from Connecticut to California. The 22nd of March 1945. Yokosuka Analysis Room, 2 floors above the shop. Windows papered against blast. A chalkboard crowded with columns, weight, span area, wing loading, power loading, rate of climb, service, ceiling range. The Corsair's stripped parts lie tagged downstairs. Up here the numbers begin to talk. Power loading first empty figures are interesting combat figures matter. With internal fuel and full ammunition, the R2800 still grants a margin that shows up as climb, where it counts from low altitude to 20000 feet. The curve looks like a hill the Zero does not want to climb. They set the Corsair next to what they know, a 6M50 Sen light agile single-stage supercharger, climb good at low-level thin protection. J2M3, Raiden strong interceptor, respectable climb, but production fit varies engine temperamental. N1K2J. Shiden Kai, formidable on paper, excellent maneuver once airborne, yet the Homare engine comes short on reliability, and wartime production roughens parts that should be smooth. The Corsair's figures do not shout in any single cell. They do something quieter. They stack advantages without a penalty that breaks the airframe elsewhere. Armor and self-sealing tanks are weight, yet the wing still carries 8 Brownings without starving the airplane of climb. 2-stage supercharging is complexity, yet the installation is neat and the duct losses are low. The realization is not a headline. It is a ledger that refuses to turn red. A liaison officer drops a folder on the table with combat reports from the Solomons and the Central Pacific. Pages smell of damp and carbon paper. The 12th of February, 1943, Guadalcanal VMF 124 flies the type's first combat. February 14, a hard lesson over New Georgia and Savo the day Marine pilots later call the street. Valentine's Day massacre coordination, ragged altitudes, mismatched tactics still borrowed from lighter types. Losses sting. Yet, by late spring, the pattern changes. New approach speeds, new brake turns written on ready room boards. May 1943 Kenneth A. Walsh VMF 1245 victories credited by early summer. Technique catches up with technology, and the curve bends. The Japanese engineers read the summaries that their own pilots have generated after facing F4US over the Solomons, then Rabaul, then the Marshalls and Marianas. They underline the same phrases, again and again: dives that hold speed zoom, climbs that do not sag the way the American pilot can take one hit to the coolant on a liquid-cooled fighter and be done. Yet, this air-cooled brute shrugs off splinters and oil streaks and still drags itself home. Reports from Truk and Palau mark rocket attacks that tear at shipping and airfields. A night entry observes a blue-black shape passing low with a strobing muzzle line and an exhaust glow like a small forge. The weapon is no longer only a duelist. It is a platform. Numbers tie to names. Squadrons move like arrows across a wall map. VMF 1, 2, 4, and VMF 2, 113 inches the Solomons. Carrier groups bring the F4U aboard after deck landing fixes and training tighten the bounce. F4US over Okinawa, escorting strikes and diving on kamikaze assembly fields. Claims and losses are imperfect mirrors, but even conservative reconciliations leave an uncomfortable ratio in the margin. Roughly 11 victories for every one air-to-air loss by VJ Day, when the type's Marine, Navy and Fleet. Air Arm career is tallied. The men at the board do not argue about exact integers. They look at trend. The trend says the machine gives pilots room to live while they learn. Back downstairs, the airframe speaks the same language. The armor plate is not decorative. The windscreen is not a gesture. The self-sealing tanks are not an engineer's memo lost in production. All of it is there repeatable. A Zero achieves lightness by cutting away failure modes. The Corsair achieves survivability by paying weight and then earning back performance with horsepower and efficiency. One approach bets on not being hit. The other assumes it will be, and survives anyway. In a war that has turned into climbing, diving, slashing, and returning to fight tomorrow, the second bet pays compound interest. They pass the gun bays again. 8 Brownings. The arithmetic of mast, 50 caliber, is not subtle, but the installation is. Feed angles gentle, access easy. Cooling paths around barrels generous. The gun heating provisions and drain points whisper about operations in rain and salt air. A clerk reads aloud a line from an intercepted Allied maintenance, circular about ammunition, quality control, and lot testing. The room does not laugh. If ammunition feeds without stoppage and primers burn evenly, then the pilot concentrates on flying. If the pilot concentrates on flying, the numbers turn again. Late in the day, a weathered officer from the flight test section leans over a set of deck landing notes collected after the type's rocky carrier trials in 1943. He traces the fixes: raised seat, better forward, view on approach, stall, strip, and flap changes, training curricula that standardize techniques squadron to squadron. The pattern repeats a problem identified and then solved across the fleet, not by individual aces, but by a system that updates the pilot's world as if the airplane were a ship class and the fleet an organism. He taps the paper and says nothing for a while. The others understand. They have pilots who improvise brilliantly. They do not always have a pipeline that makes the solution universal by next month. Dusk brings a last meeting around the chalkboard. The day's figures harden into a draft report. No single secret discovered. No magic alloy uncovered. Instead, an accumulation corrosion control that prevents tomorrow's maintenance from stealing today's performance. Jigs that remove the craftsman's heroics from final fit. Power in reserve that covers a dozen sins and invites a heavier mission set without breaking the wing. When someone asks what can be copied quickly, the answer is short. A few fittings, some duct geometries, perhaps a sight hood. The rest is not a part. It is a way of making parts. On the walk out to the yard, the bay smells of tide and coal smoke. A convoy clanks in the darkness. Somewhere a crane squeals. The engineers keep their hands in their coat pockets and their eyes on the gravel. The Corsair is real, measurable, reducible to drawings. The thing that frightens them is not the Corsair. It is the backdrop that allowed thousands of Corsairs to be the same machine under different pilots, under different skies. Upstairs, the chalkboard waits with tomorrow's column left blank. The 24th of March, 1945. Yokosuka metallurgy shop behind the test hangar. The Corsair's parts arrive in trays, wrapped with oiled paper and numbered tags. A lathe hums. A saw shrieks once and bites through a sample from a spar-cap coupon cut at the root. The slice shows grain that runs straight and tight. A technician inks the face, polishes it on cloth, etches with acid and lifts it to the light. The pattern is clean, no surprises, just a finish that speaks of consistent billet stock and heat treatment repeated 1,000 times. He sets it down and writes the same word 3 times in his notebook: uniform, uniform, uniform. Fastener samples go under a microscope. Threads are rolled, not cut, with roots that flow rather than break. Rivet tails show even swell, whole walls burnish without galling. The inspector has done this with domestic parts for years, and knows the difference instantly. When holes wander, when a jig pin is loose, the tail tells the truth. Here, the truth is that the hole and the rivet were married by a process that does not depend on a gifted man at a single bench. It depends on a tool that makes every man average and every result the same. That is a kind of power they do not stock in a drawer. In the engine cell, the team runs bench checks on accessories pulled from the R2000-800. A magneto spins on a fixture. The spark stays even across the range. A fuel pump goes to a flow rig. The curve overlays the spec plate like tracing paper. The 2-stage supercharger case is opened far enough to trace passages. Casting quality is high voids, scarce internal walls smooth where they must be smooth. They have castings this good in small runs at home. They do not have the alloys to do it at scale this late in the war, and they do not have the fuel to feed large fleets that require octane above what ration board realities can guarantee every month. Supply speaks a harder dialect than design. Opama Field sits a short walk from the shop. In calmer months, the test section would roll the airframe out for ground runs and taxi trials. Now, the priority is to record systems, not to risk a flight in a sky where strangers pass overhead uninvited. Still, they wheel out a power section with prop for stand testing, chock it, and light the double wasp. The engine comes up like a train, leaving a station heavy and certain. At intermediate boost, the bay resonates in a tone that crawls into the ribs. Oil pressure holds. Cylinder head temperatures stabilize at numbers that make sense with the baffles in place and the cowl flaps propped. A man grins without meaning to when the prop governor holds the setting across small throttle changes like a metronome. Back inside, a structures officer sketches the inverted gull planform on butcher paper and lays a zero-wing outline over it. He marks the Corsair's knuckle at the root and writes beneath it short gear, big prop, clean route. He runs a finger along the path from fuselage to gun bays to wheel wells and taps, each place where the geometry gives space that a straight wing denies. It is not just clever, it is a choice that the whole airplane supports. Stronger gear, heavier armament, larger prop disc, and the engine gives the thrust to make the choice pay. You do not copy that with a single drawing. You copy that with an engine program and a wing line and a landing gear line that all keep the same appointment on the same calendar. Radio racks get their own bench. The sets are not exotic to look at, but the build is steady. Shield cans. Fit connectors are consistent. A clerk brings in a translation of an Allied logistics note about spares pools aboard escort carriers and forward depots. The room is quiet for a moment. Radios that match in plug and pin count across squadrons mean a swap in minutes, not hours. A site that holds 0 after a deck landing, because the mount is overbuilt by 10%, means a pilot does not adjust on takeoff and discover drift in the first burst. Every small certainty refuses to let chaos in. They disassemble a length of control cable and mic the strands. The numbers line up with the tag. They measure clamp intervals and find rhythm in the inches. They follow a loom through a bulkhead and note the grommet spec, then find the same grommet again 3 stations aft. The more they map, the less they are surprised. Surprises are the hallmark of improvisation. This airplane has none in the places that matter. The surprise is the lack of surprise. A senior engineer walks the line of trestles with a clipboard that holds 3 questions at the top. What can be reproduced with current stock? What can be substituted without penalty? What must be acknowledged as out of reach? He checks boxes. Zinc chromate. Small batches possible, not enough for fleet practice. Rolled thread fasteners. C. Yes, but the die life will be short on current steels. 2-stage supercharger performance. AAT. Drawings can be traced, but alloy temperature margins and bearing life will limit the result. He draws a bracket around the last line and writes in block letters, "The part is the factory." Evening brings a brief meeting in a room that smells of hot metal and tea. The draft report now has bones. Strengths listed: robust structure, uniform manufacturing, effective corrosion control, reliable accessories, integrated weapons, installation survivable systems. Vulnerabilities noted: large, heavy requires runway or carrier deck discipline approach view still limited, despite fixes, maintenance burden significant, but well supported in its service. Recommendations follow that read as honest rather than optimistic. Adopt clamp spacing standards, enforce jig checks at line start and line end, standardize radio racks, study duct geometries for intercooling. The uncomfortable paragraph sits last. Without fuel, alloy and time, these are islands. A system is a continent. They shut down the lights over the parts forest. Outside Opama's field lies black under a sky that keeps its own counsel. Somewhere far off, a bomber drags a sound across the wind that no one mistakes anymore. The men lock the shop and walk past the Corsair's fuselage, now a clean spine on stands. No magic, no myth. Only a set of answers that repeats itself in every tag and every gauge. They have measured an airplane. What they have really measured is the distance between 2 ways of making war.